Hello everyone. In this chapter, we will cover the basics of data collection. From chapter 1, we know that statistics is a data science. But where do we get data? How do we collect data? This is what we shall address in this chapter. First, let's talk about some definitions. What is data? Data are values of qualitative or quantitative variables. A data set is a particular collection of data values as a whole. Observation refers to each data value. A subject or an individual is an item for study, for example, an employee in a company. Variables refer to a characteristic about the subject or individual that we want to study. An employee's income is a variable. So are the employee's age, gender, and education level. Depending on the level of variables involved, there are different types of typical tasks to be performed. If I have only one variable in the data set, we call it univariate data set. And mathematical tasks we can perform on that kind of data are constructing a histogram, doing descriptive statistics, and count its frequencies, etc. When you have two variables in a data set, that's called bivariate. With two variables, we can do scatter plots, run correlations, and simple regressions. If you have more than two variables, then we call that data set multivariate. We can do multiple regression, data mining, and econometric modeling on that. We will not be dealing with that with the multivariate data in this class. The chart on slide number 4 summarizes the types of data and gives you some examples of each. There are two types of data, qualitative or categorical, and quantitative or numerical. For categorical data, we can have verbal labels on them, such as, we can use car, truck, or SUV for different types of vehicles, or male or female for gender. Or we can code data by labeling car, truck, or SUV using the number 1, 2, or 3 instead of the names. We can code the two gender items 0 and 1 for man and woman. On numerical data, the data could be discrete or continuous. Discrete numbers are whole numbers, whereas continuous numbers are with decimal point or fractions. For example, the number of broken eggs in a carton is discrete, as you can have only whole numbers from 0 to 12 for the number of eggs that are broken. The number of annual visits to your dentist is also discrete. You can visit your dentist 0 times, 1 time, or 2 times, but not 1.3 times. The time a patient waits in a clinic is continuous. The average number, say, could be like 14.27 minutes. So is the customer satisfaction score, such as 85.2%. That is also continuous. Keep in mind that the ambiguity is introduced when continuous data are rounded to whole numbers. So be cautious about that. Data are usually obtained by some measurement process. How do we measure things? What are the types or levels of measurements? There are 4 levels of measurements. The first level, or the lowest level, is nominal. Nominal measurement deals with categories only, such as when we describe the color of one's eyes in blue, brown, green, or black. A higher level of measurement is ordinal, when the rank order has meanings. A good example of which is bond rating, whereas we rate the bonds issued by government entities or corporations as having ratings such as AAA, AAB, C, or D, etc. The next higher level of measurement is interval, where there is a rank order of measurement as well as meaningful distance between the ranks, such as a measurement of temperature. We may say that the temperature is 57 degrees Celsius, and the temperature of 57 degrees Celsius is 10 degrees higher than 47 degrees Celsius, and 15 degrees higher than 32 degrees Celsius. The highest level of measurement is ratio. In ratio measurement, not only does it have the properties of all three levels of nominal, ordinal, and interval, but a meaningful zero exists. When we talk about measuring money, for example, $21.7 million, that's a ratio measurement. $0 is meaningful. Again, nominal measurement identifies categories, such as using 1 to code Apple computer, 2 for compact computer, 3 for Dell, and 4 for HP, etc. Ordinal measurement data coded can be ranked, such as 1 being frequently, 2 as sometimes, 3 as rarely, and 4 as never in measuring a person's usage frequency. In ordinal measurement, distance is not meaningful. Many useful statistical tests exist for ordinal data. It is especially useful in social science, marketing, and human resource research. In interval measurement, data can not only be ranked but also have meaningful intervals between scale points. And since intervals between numbers represent distances, math operations can be performed, such as calculating averages. Remember, 0 point of interval scale is arbitrary, so ratios are not meaningful. Ratio data, as said, have all the properties of nominal, ordinal, and interval type data types, and also possess a meaningful zero. That is, absence of quantity is being measured. Because of 0 point, ratio of data values are meaningful. For example, $20 million in profit is 12 as much as $10 million. One measurement scale that you probably have heard about is the Likert scales, which is a special case of interval data frequently used in survey research. The coarseness of a Likert scale refers to the number of scale points, typically 5 or 7. This is an example of a Likert scale on slide number 10, whereas there are 5 answer choices given: strongly agree, some would agree, neither agree nor disagree, some would disagree, and strongly disagree, for the question of college-bound high school students should be required to study a foreign language. Another sample question is, how would you rate your marketing instructor? The answer choices given are terrible, good, adequate, good, or excellent. And the respondent is supposed to check any one of 5 choices. Now, how do you determine the level of measurement? This slide gives you a good method. First, you ask yourself, is there a meaningful 0 point in the data? If the answer is yes, it's ratio data. If the answer is no, you ask, are intervals between scale points meaningful? If yes, it's then interval data. If no, you ask another question. Do scale points represent the rankings? If the answer is yes, it's ordinal data. And if no, and there are discrete categories described, you know it is nominal data. The type of data can be changed by recoding. In order to simplify data, or when the exact data magnitude is of little interest, ratio data can be recoded downward into ordinal or nominal measurements, but you can't do it conversely. You can only go from higher to lower, not lower to higher. For example, when we measure blood pressure, we can use the exact ratio data of mercury height of 120, 130, or 145, or we can recode it downward to nominal pressure if it is under 130, elevated. We say normal pressure if it's under 130, elevated if it's between 130 and 140, or high blood pressure if it's over 140. This newly recoded data are ordinal, as ranking is preserved, but intervals are unequal and some information is lost. There are also the concepts of time series data versus cross-sectional data. Time series data is one where each observation in a sample represents a different, equally spaced point in time, such as in year, month, or days. The periodicity could be annually, quarterly, monthly, weekly, daily, or hourly, etc. We use time series data when we are interested in trends and patterns over time, such as the annual growth in consumer debit card use from 2001 to 2008. On the other hand, in cross-sectional data, each observation represents a different individual unit, such as a person at the same point in time. The key here is at the same point in time. For example, the monthly Visa balances of all cardholders. We use this type of data when we are interested in variation among observations or in relationships. Of course, we can also combine the two data types to get pooled cross-sectional and time series data. Next, let's talk about the sampling. There are some sampling concepts we need to learn. When we collect data, sometimes we use sample, and some other times we would use census. A sample involves looking only at some items selected from the population. A census is an examination of all items in a defined population. The United States Census is a census that is supposed to examine all people in America, which is done every 10 years, but is not always done on all and everyone for some reason, for many reasons. So when do we use sample and when do we have to do a census? When we have an infinite population, the testing is destructive. We need timely results, high accuracy is needed, cost is high, and involving sensitive information, then a sample is preferred. When the population is small, sample size is large, there exists a database or is required by law, a census then is probably a better choice. Now let's talk about the parameters and statistics. Statistics are computed from a sample of n items, that's lowercase n, chosen from a population of n items, capital N. Statistics can be used as estimates of parameters found in the population. Symbols are used to represent population parameters and sample statistics. We use Greek letters, mu for population mean, and pi for population proportion. For example, we use x bar for mean for sample, and p for proportion. A rule of thumb is a population may be treated as infinite when n is at least 20 times, the capital N is at least 20 times the lowercase n. In survey research, we need to get a sample that is representative, so we need to select our target population. The target population is a population we are interested in, for example, the U.S. Gasoline prices. The sampling frame, on the other hand, is a group from which we take the sample. For example, 115,000 gas stations. The sampling frame should not differ from the target population. There are different ways for us to collect our samples. By simple random sample, we use random numbers to select an item from list. For example, the Visa card holders. Right? A systematic sample is where we select every kth item from a list of sequence. For example, restaurant customers. Right? A stratified sample is where we select randomly within defined strata. For example, by age, by occupation, or gender. A cluster sample is like a stratified sampling, except the strata are geographical areas, such as zip codes. A judgment sample is to use expert knowledge to choose typical items. For example, which employees to interview. A convenience sample uses a sample that happens to be available. For example, ask co-workers' opinion at lunch. A focus group is used where an in-depth dialogue with a representative panel of individuals, for example, iPod users, is conducted. When we choose our samples, if we allow duplicates when sampling, then we are sampling with the replacement. If we do not allow duplicates when sampling, then we are sampling without replacement. The table on slide number 22 shows different ways of using computers to get random samples. You are encouraged to try it out using your own computers. In systematic sampling, we choose every cake item from a list, such as in this example, starting with the second item, we choose every fourth item from the list. So that's the item highlighted in blue, and to select our sample. Stratified sampling is done by dividing the population into strata, and then we randomly choose from each stratum our sample. For example, from a population containing 50% male and 40% female, we can randomly sample from 110 males and 90 females, for a total of n of 200. Cluster sample is a stratified sample, with strata consisting of geographical regions. In one-stage cluster sampling, samples consist of all elements in each k randomly chosen subregions, that's clusters. In two-stage cluster sampling, we first choose k subregions, clusters, then choose a random sample element within each cluster. This chart here on slide number 26 show how a cluster sample sampling is done. We first choose three clusters, highlighted in yellow, and then choose randomly from each cluster 3 or 4 items. Judgment sample is a non-probability sampling method that relies on the expertise of the sampler to choose an item that are representative of the population. It can be affected by subconscious bias, for example, the non-randomness in the choice. A quota sampling is a special kind of judgment sampling in which the interviewer chooses a certain number of people in each category. A convenience sample is done by taking advantage of whatever sample is available at that moment. It's a quick way to sample. Focus group sampling is done with a panel of individuals chosen to be representative of a wider population for open-ended discussion and idea gathering. Slide number 29 lists some of the data sources to help you learn where to find data that you may need. Many excellent sources are available and many are free. Now let's talk about survey research to gather data. The basic steps of survey research are: step 1, you state the goals of the research. Step 2, develop the budget. This is the budget for time, money, and staff. Step 3, create a research design. That is your target population, sampling frame, and sample size. Step 4, choose a survey type and method of administration. Step 5, design a data collection instrument that is such as a questionnaire. Step 6, you should pre-test the survey instrument and revise as needed. Step 7, administer the survey to the follow-up if you need it. And step 8, codes data, and analyze it. There are different types of surveys, such as a mail survey, telephone survey, interview survey, web survey, and direct observation surveys. In conducting surveys, you need to plan it, design it well, ensure quality, test it, and use buy-in and expertise when needed. In designing your questionnaire, make sure you use a lot of white space in layout. Begin with short, clear instructions. State the survey purposes, assure anonymity, and instruct on how to submit the completed survey. You may break the survey into naturally occurring sections, like respondents bypass sections that are not applicable. For example, if you answer no to question number 7, skip directly to question number 15. You should pre-test and revise as needed, and also you should keep the survey as short as possible. As to the type of questions in survey, you can use open-ended questions, ask them to fill in the blanks, use checkboxes, provide them with ranked choices, or use pictograms, or use the liquor type scales. With regard to question wording, the way a question is asked has a profound influence on the responses. For example, if you ask this question, should the state tax be cut? You will get a certain response. Right? If you ask, shall the state tax be cut if it means reducing highway maintenance, then you will get a different set of responses. If you ask this question like, shall state taxes be cut if it means firing teachers and police, then the answers you get will still be different. Also, in question wording, make sure you have covered all the possibilities. For example, for the questions that are you married? If you only provide answers yes and no, those who divorced or are widowed will find it difficult to answer. Also, look at the sample given here on slide number 38. Do you see any problems? Let's see, if someone is 45, how should the person answer? Should the person check the first choice or second choice? The first choice is 35 to 45, second from 45 to 55. So make sure you do not have overlapping classes or unclear categories. And in coding and screening your data, you should code all responses numerically. You should denote missing values. Discard questionnaires that are flawed or missing many responses. Watch for multiple responses, outrageous or inconsistent replies, or range answers, and follow up is necessary, and always document your data coding decisions. That's all we have for Chapter 2, Data Collection.